Hello everyone. In this video, I am going to discuss Cpget 2021 Mathematics previous year questions. In previous videos, I was solved some questions. So in this video, we will solve the remaining questions. So the question number 66. So let G be a group of order 75 and HK are the two subgroups of G of order 25. Then find the order of H intersection K. So for finding the order of H intersection K, we have one formula for this one, that is order of HK is equal to order of H into order of K, order of K divided by order of H intersection K, order of H intersection K. So what I did, I just take it out into left hand side, order of H intersection K, then I get it order of H intersection K is equal to order of H into order of K divided by order of H K. So order of H is given that 25 and order of K also is given that 25. So we get 25 into 25 divided by, so order of HK is the GCD of H and K. So the GCD of H and K is only 25. So we get that 25, 25. With the answer we get 25. So order of H intersection K is 25. So that is the correct answer for this question. So question number 67. Find the characteristic of a Boolean ring. So we know that Boolean ring is, suppose R is a Boolean ring, then the every element of this in this ring is contain identity idempotent element. Suppose A square equal to A. For every A belongs to R. This is the condition for satisfying idempotent element. If it is satisfied this condition, we can say that that is the idempotent element. So the every element of in this ring is satisfies the A square equal to A. So the order of every element is 2. So he is asking the characteristic of a Boolean ring, means it contains only two elements in this ring, 0 and 1. So the characteristic of these elements will be 2. So this is the correct option for this question. 68 one is find the characteristic of a ring Z2 cross Z4 cross Z6. So whenever these type of question come, so the formula is for finding the characteristic of a ring is LCM of these terms 2, 4 and 6. So 2 comma 4 comma 6 LCM, we will get the answer. LCM of 2, 4, 6 is clearly 12. So we get, that is the answer for 68th question. And 69th one is find the units of Z12. So the ring of a residue classes of modulo 12. So he is asking the units. So if we ask the number of units, means we get a formula is phi of n. So he is asking the unit elements of Z12. So unit element, when we call it is as a unit element, suppose I have a element A, and if I did some binary operation with respect to addition or plus whatever it is, so if I get 1, then I can, every non-zero element has a multiplicative inverse, then only we can say that that is a unit element. So here clearly see that first option. So 1, 5, 7 and 11 is there. So if I did 5 into 7, I get 5 into 7 is 35. So if I did with modulo 12, I get it as a 1. I get it as a -1. If you doing continuing this process, you get 1 as a modulo 12. So then we can say that 5 and 7 are the multiplicative inverse to each other. For 11 is a self multiplicative inverse, because 11 into 11 will give the 121. If you do modulo with modulo 12, you get that only 1. So 11 is the multiplicative modulo inverse. So one is the identity, then we can say that clearly this option is the correct one, and the elements are the unit elements of Z2F. So the question number 70 is, if F is a 1-1 homomorphism of a ring or into a ring or dash, so then find the kernel of F. He already told F is a 1-1 homomorphism. When 1-1 homomorphism is possible, the kernel of F is identity. So by the first fundamental theorem of isomorphism, so we can say that kernel of F is identity. So identity is here, additive identity, we get it as a 0, singleton 0. And the question number 71 is, which one of the following sets is linearly dependent? So whenever these type of questions, linearly dependent or independent type questions are come, I will tell you the one shortcut trick. That is, we can directly find the Wronskian, means determinant of the that set of elements. So if you solve the determinant of, you tell that fourth option is the correct one. So if you do the determinant of the elements, either it is column or you can write in row. So if you can clearly get it, you can clearly get it, determinant is goes to 0, then it is a linearly dependent. If determinant is non-zero, means the set of vectors are linearly independent. Okay, so this is a short trick. Whenever he is asking either linearly dependent or independent, you may use this method, so that is easy to solve. So if you solve determinant to other vectors, you can get non-zero determinant. So because they are linearly independent, so except this set, all sets are linearly independent. Okay, the question number 72 is, the characteristic polynomial of 3 cross 3 matrix A is A minus lambda I is equal to lambda cube plus 7 lambda square minus 5 lambda plus 1. Then find the determinant of A. He is asking the determinant of the characteristic polynomial of this one. So there is a, if you write directly the characteristic of a matrix A, that is trace of A lambda cube minus trace of A lambda square plus principal cofactors of that diagonal vectors. We can return that one, lambda minus determinant of A is equal to 0. This is the general normal form of the characteristic polynomial. If you compare with this one, we get that determinant negative is there here, positive is there. So the determinant of a characteristic polynomial is -1. So we can clearly see that way. So -1 is the correct option. 73 question. Which one of the following sets is basis for the subspace W? So he mentioned that this is the base subbase. So subbase means if you do vector addition and scalar multiplication, it is contained inside of W. It is contained inside of W. So what? How can we proceed for finding the basis? What I did, I just took that y is equal to y. He provided some conditions. Y plus 3 is equal to 0 and x plus 2y plus t equal to 0. He already given in question. So what I did, from this I can find the value of x and y. So I get y is equal to minus t. If I substitute this value in this equation, I get x plus 2 into minus 1 minus t plus t is equal to 0. So from this we can get it as x equal to t. So we have x equal to t and we have x equal to minus t. So if you substitute the values in from the given subbase, we have x, y, 0, t. So if I substitute those values from here, so I get t minus t, 0 and t. If I take the common of t, I get 1 minus 1, 0, 1. So this is the basis form of the given subbase. So this is the correct option, that is second one. Second one is the correct option for this question. So the question number 74 is, so find the rank of the matrix 1 1 1 A B C, rank of this matrix where A equal to B and but B not equal to C. So he provided some condition like this. So for this we can simply solve this one. This is very simple. What can you do? You just consider whatever the values, whatever you want values of A B C. So but applying this condition. So I just considering A is equal to, he mentioned that A equal to B. So for AB value I can consider as a 1 and C value I consider as a 0. So just substitute the values in the given matrix. So we get it as 1 1 1 and AB we consider as a 1. So I just write 1 1 here and C value I write as a 0 and A square B square C square. So that is 1 1 0. So if you do the row operation R2 minus R3, you get it as a 1 1 1 1 1 0. So 0 0 0. So you can clearly see that the rank of a matrix in echelon form is only two rows are linearly independent. So you can say that rank of a matrix is 2. So there is a one null space is there. So the rank is only 2. So the option 3 is the correct option for this question. So for any real square and non-singular matrix B, yeah, this is the direct statement. You can directly say that. If you remember in the statement, you can directly say. Otherwise, you just take the one example B as a one matrix A, B, C, D, because he mentioned that the matrix is a square matrix. Okay, so you can consider, I just simply consider 2 plus 2 matrix and you can do the inverse of this matrix and do the determinant of this one and you will get like this way. It should be satisfied this condition definitely. That is a direct statement. So the 76th question is, let V be a vector space all 2 cross 2 matrices over a field left, then dimension of V. So he is asking the dimension. Whenever dimension question come, so here 2 plus 2 he mentioned. So when in general case, if it is n cross n is there, you can directly write n square. So that is the direct formula for that. So in place of n we can replace as a 2, we get it, the dimension is 4. So that is the correct option. So 4 is the correct option for this question. So 77 is, he is asking find the coordinates of the vector 2 comma 1 comma minus 6 of r cube relative to the order basis. So the basis order basis are 1 comma 1 comma 2 and 3 comma minus 1 0 and 2 0 minus 1. So this is very simple. I will tell you the idea how to solve this question. So he is asking the coordinates of a vector. So when we say coordinates of a vector, so suppose our basis is 1. We mentioned a 1 comma 6. So I can write that order basis like this way. Suppose A into 1 comma 1 comma 1 comma 2 plus B into 3 comma minus 1 comma 0 plus C into 2 comma 0 comma minus 1. So from this we get three equations. So these are the, he is asking the values of A, B, C. So he directly asking the values of A, B, C. These are the coordinate vector. So you can do two methods. That is, if you substitute directly A, B, C value by verifying the options, or otherwise you may solve, you will get three equations. That is, if you multiply A to this one and B to this one, C to this one, you will get C three equations. That is A multiply with A plus B multiply with 3B plus C multiply with 2 to get 2C is equal to this one, first vector of element. So we get one equation. Similarly, you will get three equations. If you solve those things, you directly get the answer minus 7 by 8 comma minus 15 by 8 comma 17 by 4. So you get this vector. So that is the coordinate vector of a given basis. So the 78th question is, so let B1 is 1 comma 2, 3 comma minus 1, B2 is 1 comma 0 comma 0, 1 comma 1 comma 0, 1 comma 1 comma 1 is a basis vector of vector space R square and R cube. So relatively over P log. So define a one linear transformation T R square to R cube. So he is asking that find the matrix of a relative basis of V1 and V2. This is a big process, but I will tell you the idea how to solve this one. So suppose I have a matrix A. He already provided the two basis vector V1 to V1, V1 to V2. So you just do the by using these standard basis and order basis, you will get one matrix A. So that matrix is a given matrix. So this is the formula. By using these basis, you can find the matrix. So question number 79. Find the eigenvalues of a matrix. E given one matrix, and he is asking the eigenvalue of this matrix. We know that the sum of the eigen three. Suppose this is a 3x3 matrix. The sum of three eigenvalues is trace of a matrix. So what I did, a trace of a matrix means minus 2 plus 1 plus 0. So the sum will be give a minus 1, and the product is the determinant of this matrix. So if you do the determinant, you directly get the answer. So that is, if you add this eigenvalues, you get it 5 comma 5 minus 3 minus 3, that will give you minus 1. So the two, but another option is also going to match, I think. Minus 5, no, there is no option. So by adding two, by adding the trace of a matrix, you get that minus 1, that is the sum of eigenvalues. So you can directly verify. If you add these values, you never get minus 1, and if you add this one, you get plus 1. So that is not possible. If you add this one, you get minus 5. So that is also not possible. Directly you can verify the sum of eigenvalues is minus 1. So these are the eigenvalues of a given matrix. So the 18th question, the null space of a linear transformation T from R cube to R square he defined one linear transformation T x comma y comma z is x plus y comma z is spanned by which one of the following vectors? He is asking that null space. So whenever null space will give, so for this question we can directly say by using the options. So when it is going to 0, so the identity will never happen because he is asking non-zero one. So if you substitute x, y, z values from here, you directly get it. Suppose if I put 1 here and minus 1 here and 0 here, so it will give you minus 1 and 0. So you will get 0 comma 0. So this is the null space for given linear transformation. So but if you substitute these values, you never get 0 comma 0. You will get, if you substitute the third option, you will get 2 comma 1. If you substitute the fourth option, you will get 1 comma 0. So only these will be form a if satisfy the given null space condition. So that is the correct option for this question. So 81. Let V of f is a inner product space for alpha beta belongs to V of f. Which one of the following is true? So this is a direct statement. So he provided some statements, and which one is the true? He is asking which one is the true. So this is the true statement, because if it is satisfied these conditions, then we can say that he mentioned already it is a inner dot product. So it must and should be satisfied this condition. So this is the correct option. For 82 question, find the unit vector of orthogonal to 4, 2, 3 in a inner dot product space. So whenever orthogonal will come in examination, you just remember that the orthogonal, when we say orthogonal, if you take one vector v1 and if you take another vector v2, and if you do the dot product, so the dot product will goes to 0, then we can say that is a orthogonal. Okay, so this is he provided already v1 value 4 comma 2 comma 3. In place of v2, you just take one by one vector by option verification. So this should be satisfy the condition, but identity will never work because he is provided non-zero one. So we will use non-zero one only. So that will give you 2 by 3 and minus 1 by 3 and minus 2 by 3. If you do this one, you will get definitely 0. 0 is the answer. So that is the orthogonal to 4 to 3. So this is the correct option for this question. The 83 one, if alpha beta are orthonormal vectors in a inner product space, then find the distance between alpha and beta. So we know that. So when we call it as a orthonormal, so if you take two vectors v1 and if you do the dot product v2, it is goes to 1. Then only we can say that this is a orthonormal vector. So if you just take randomly two vectors v1 and v2 and do the dot product, then whether it is satisfying the orthogonal condition or not, then take the difference of distance. Distance means you is asking distance. So you just take two randomly whatever you want. So D, E, F. These are two. I just assume that these are two orthonormal vectors. So if you find the distance for this a minus d by applying the distance formula, so that will give b minus e whole square plus c minus f whole square. So it will give you the distance of that orthogonal. It will definitely go to root 2 by whatever orthonormal vector you will take. So 3 is the correct option for this question. So you just take the two orthonormal vectors and you just find the distance for that. You definitely get root 2. And 84 one is if SC is equal to alpha 1 alpha 2 up to alpha m is an orthonormal set of an inner product space. This is also direct statement. You can directly say that option 1 is the correct one. And 85th one, if product of two eigenvalues of a matrix, given matrix, he provided one matrix, he is saying that the product of eigenvalues of a matrix is 16 and find the third eigenvalue of he is asking to find one eigenvalue of a he provided product of two eigenvalues is 16 and he is asking to find a third eigenvalue of a given matrix. We know that product of eigenvalue is equal to determinant of a matrix. So I can write, I suppose if I consider as a so determinant of A. So the product of eigenvalues of determinant of A. So what I did, he already provided some product of two eigenvalues is 16. So if you take 16 one and you need to find the third eigenvalue. So if you do the determinant, you get some k. I don't know what is k. You can do it. So you get k. For that k, lambda 3 k divided by 16. So this is the one eigenvalue for this matrix. So for in place of k, you will get 32. The determinant is 32. So 32 divided by 16 will give you a 2. So that is the eigenvalue for this matrix. So you need to know this method how to approach the question whenever he is asking the product or when he is asking the sum of the eigenvalues. So you need to know that one. So 86th question is suppose that f of 0 equal to 1, f of 0.5 is equal to 2.5, f of 1 equal to 2 and f of 0.25, f of 0.75 is alpha. By composite trapezoidal rule with n equal to 4 gives the value 1.75 for 0, 1 fx dx, then find the value of alpha. He is asking to find the value of alpha. For this, I will give the idea. We know that the trapezoidal rule formula is there. That is, I can write it here. You just apply that one, you definitely get the direct value. Suppose if I have a comma b fx dx is equal to h by 2. Here h is like b minus 2. So h is approximation b minus a by n. So y naught plus 2 into y1 y2 up to yn minus 1 plus yn. So if you apply in place of y, you can take one. This is the y naught value. This is the y1 value. This is the y2 value, and the y3 and y4 value is alpha. If you substitute those values and equate with, we already provide 1.75, equate that with this one, so you definitely get the value of alpha as a 1.5. So you will get the alpha value is 1.5 definitely. You just substitute the values of y0, y1, y. So that is the correct option for this question. So similarly, if you apply the Simpson's 3 by 8 formula, you definitely get the answer. Just substitute the values whatever that formula is there. So I will give you that formula also if you want. Then that is A to B. Just substitute the values whatever there in this. He already given all the conditions. 3h by 8 y naught plus 3 into y1 plus y2 up to so on. Y4 is also there. Y3 terms are the multiples of 3 are we are not including here. We will write out of the, yeah, this is 2 and y3 is so on into, you can write yn. So this is the formula for Simpson 3 by 8 method. So you just substitute, consider as a y naught this one, and y1 this one, y2 this one, and y3 this one. So we already just substitute the values from here, and h equal to similarly here also b minus a into divided by n. N means how many number of repetitions are there? 1, 2, 3, 4. 4 are there, so n value should be 4, and we already provide b and a, that is 0, 3 by 4 is a h value. If you substitute like this way, h value is 3 by 4, so and y value is also, you will get directly the value of this question. So that is minus, that is 1.2. Yeah. Okay. So if you really enjoy the video, then try to like the video